So we just had a good review of dividing fractions, and now we'll do a good review of dividing with decimals. And there are a couple of different examples that we have to look at. The first example we're going to look at is when we have a whole number divisor. We have 20 and 8/10 divided by negative 16. This number that you're dividing by is called the divisor, and this divisor is whole. This is a whole number divisor. If you're dividing by a whole number, then the decimal in the dividend simply moves straight up into the answer. And so let's see what this looks like. Okay, remember, you can rewrite this division problem like a fraction. All right, the first number, 20 and 8/10, would be our numerator, and our denominator would be negative 16. And we want to do the division problem here. So what we're going to do, we're going to set up our long division. And the numerator is always what goes inside. Okay, so 20 and 8/10 is going to go inside of our division box. And we're dividing by negative 16. So again, if we're dividing by a whole number, then the decimal in the dividend simply moves straight up into the answer. Okay, so let's go ahead and do our division. We'll worry about the signs at the end. 16 goes into 20 once. 1 times 16 is 16. So when we subtract, we're left with 4. We bring down the 8. Okay, make sure you're lining everything nicely up here. And now we have to figure out how many times 16 goes into 48. Well, 16 goes into 48 3 times. 3 times 6 is 18, carry the 1. 3 times 1 is 3, add 1 is 4. And look at that, we have a 0 remainder. And now pay attention to the signs. A positive divided by a negative would be a negative. And so our answer here is negative 1 3/10. Okay, so this is the easiest example if your divisor is a whole number. Again, just take the decimal in the dividend and move it straight up into your answer. So what happens if the divisor is a decimal? If you are dividing by a decimal, then you can just move the decimal point to the right until you create a whole number. For example, if we have 13 and 4/10 divided by 6/10, we're going to rewrite this as a division problem with fractions, and then we're going to ask ourselves what this division looks like. So 13 and 4/10, I'm going to write it just like that, 13 and 4/10 divided by 6/10. That's what it would look like with fractions. I'm going to make this mixed number a fraction. 10 times 13 is 130 plus 4, so this would be 134/10 divided by 6/10. And notice that these have common denominators. So if I were to divide across, the denominator would be a 1, and the numerator would be 134 divided by 6. So this just turns into the fraction 134 divided by 6. So if I were to make this a long division problem, again, the numerator goes inside the box, 134 divided by 6. Doesn't this look very similar to what we started with? Notice these are whole values. All we would have to do is move that decimal over to the right 1 time. So let's show that now. Okay, so we have 13 and 4/10 divided by 6/10. All right, inside would be 13 and 4/10 divided by 6/10. I want this number to be whole, so I'm going to move the decimal once to the right because that creates a whole number. And if I move it to the right once here, I've got to move it to the right once here. And now the decimal moves straight up into our answer. So let's go ahead now and do our division. 6 goes into 13 twice, so put the 2 above the 3. 2 times 6 is 12. When we subtract, we're left with 1. Bring down the 4. 6 goes into 14 twice again. 2 times 6 is 12. So when we subtract this time, we're left with 2. I'm going to add a 0 inside and bring it down. 6 goes into 23 times, so the 3 goes above that 0. 6 times 3 is 18. I subtract, I'm left with 2. And I add a 0 again, I bring it down, and I just did this. All right, 6 goes into 23 times. That's 18. I subtract, and notice what's happening here. We're just going to keep getting this over and over again. So this is going to be a repeated decimal. Okay, so we start out with 22, so our answer here is going to be 22, and it starts to repeat after the 10th place. So I'm going to mark this as a 3 And I'm going to put a bar over the top because that 3 is going to repeat forever. 22 and 3/10 repeated. In the next example, we have 8 divided by 1 and 1/10. 8 goes inside, 1 and 1/10 is outside. And again, I want this to be whole, so I'm going to move the decimal once to the right. So I need to do the same thing here. So there's where the decimal would be. I move it once to the right. I fill in the empty spot with a 0, and that decimal point comes straight up. And so now we have 80 divided by 11. 11 goes into 87 times. That's 77. When I subtract, I'm left with 3. Add a 0, bring it down. 11 goes into 30 twice. That's 22. I subtract, and I'm left with 8. And there's my 80 again. I know that goes in 7 times. There's my 77. I bring down a 0. 11 goes into 33 2 times. And notice this will repeat again.
Let's go ahead and practice dividing our decimals here. In the first example, I have negative 5,056 10,000ths, and I'm going to divide it by 800ths. And paying attention to the signs, all right, I know that a negative divided by a positive is going to be a negative. So I'm going to get that there in my answer. And then I'm just going to set up my long division right here. So I'm just going to use 5,056 10,000ths here on the inside. And I'm going to divide it by the 800ths on the outside. I'm not going to worry about the signs here because, again, I already know my answer is going to be negative. All right, now the number outside, this is your divisor. You need this to be a whole number. Right now it's 800ths. To make it a whole value, we're going to move it twice to the right. If you move the decimal twice to the right on the divisor, then you need to do the same thing on the dividend. And now I have 50 and 5600ths divided by 8. This decimal comes straight up, and now we can do our division. 8 doesn't go into 5, but it goes into 50 6 times. 6 times 8 is 48. We're left with 2, and we'll bring down the 5. 8 goes into 25 3 times. 3 times 8 is 24. We're left with 1, and we'll bring down the 6. 8 goes into 16 twice. 2 times 8 is 16. Our difference is 0, so we're done. And so now we know that our answer is going to be negative 6 and 32 hundredths. In letter B, we have negative 6 and 2/10 divided by negative 9/10. Again, looking at the signs, a negative divided by a negative is going to be a positive quotient. So I'm going to set up my long division. All right, my dividend is going to be this 6 and 2/10. My divisor is the 9/10. And I need this divisor to be whole, so I'm going to move the decimal once to the right, which means I'll do the same thing on the dividend. So I have 62 divided by 9. Decimal's going to come straight up. 9 doesn't go into 6, but it goes into 62 6 times. 6 times 9 is 54, which means we're left with 8 as the difference. Add a 0, bring it down. 9 goes into 80 rather, 8 times. 8 times 9 is 72. We subtract, we're left with 8. We add a 0, bring it down, and we have 80 again. Well, 9 goes into 80 8 times. 8 times 9 is 72. The difference is 8. Add a 0, bring it down, and we can see what's going to happen here. We're getting a repeated decimal. So our answer again is going to be positive because the signs here were the same, and it's going to be positive 6 and 8/10 repeated. All right, this decimal starts to repeat after the tenths place, so I only need the tenths place, and I'll put a bar over the top of the 8. Letter C, we have 4 and 32 thousandths divided by negative 1 and 2/10. Looking at the signs, a positive divided by a negative is a negative, so I'll get that in my answer. And now let's set up our long division. Our dividend, 4 and 32 thousandths, and our divisor, 1 and 2/10. Divisor needs to be whole. I'll move the decimal once to the right. So I'll move the decimal once to the right on my dividend, and now I'll move the decimal straight up. So we're doing 40 and 32 hundredths divided by 12. 12 doesn't go into 4, but it goes into 40 3 times. 3 times 12 is 36. The difference is going to be 4. Bring down your 3. 12 goes into 43 3 times again. which was 36. 12 times 3 is 36. The difference, 43 minus 36, is 7. Bring down your 2. And then 12 goes into 72 6 times. 6 times 12 is 72. Our difference is 0. So we know that the quotient up here is going to be negative 3 and 36 hundredths. In this section, we're going to be converting fractions to decimals. Remember that fractions are rational numbers. All right, the root word of rational is ratio, and a ratio looks like a fraction. So if you can turn a number into a fraction, then it's a rational number. The numerator and denominator of the fraction must be whole, meaning that your fraction can't have fractions in it or decimals in it. The numerator and the denominator have to be whole. And the denominator of your fraction is not allowed to equal 0, all right, because then you would be dividing by 0, which is undefined. A fraction also represents a division problem. All right, to convert a fraction to a decimal, we will use long division, just like we did when we were dividing with decimals. The answer to these division problems will always be decimals that repeat in a pattern or decimals that terminate, which means that they will stop. Okay, any decimal that repeats in a pattern forever is rational, and any decimal that stops or terminates is also rational. Okay, so let's see if we can convert some fractions into decimals using our long division. In example number 1, they would like us to convert the fraction 7/8 into a decimal. So I am going to set up my long division. And when I do this, my numerator is my dividend, which is going to go inside of the long division box. My denominator, 8, is my divisor. All right, and my divisor is already whole, so I don't have to worry about moving decimal points at all. So all I'm going to do is my division. All right, 7 is the same as 7 and 0 tenths. So what I'm going to do is bring that decimal point straight up into the problem here. And now 8 can't go into 7, so I'm going to put a 0 there. But 8 does go into 70 8 times. 8 times 8 is 64. 70 minus 64 is 6. I'm going to add a 0 inside, and I'm going to bring it down. And now I need 8 to go into 60. 8 does go into 60 7 times. 8 times 7 is 56. 60 minus 56 is 4. I'll again add a 0 and bring it down. 8 goes into 40 5 times. 5 times 8 is 40. 40 minus 40 is 0. And now I've reached the end of the problem. All right. So the fraction 7/8 is equal to the decimal 875 thousandths. This is an example of a terminating decimal, and it's a terminating decimal because the decimal stops. All right, so if you set up your long division and eventually you get a remainder of 0 here, that means your decimal is going to terminate. All right, so this 7/8 is equal to 875 thousandths, which again is a terminating decimal. In example number 2, we're going to convert the fraction 11/15 to a decimal, again using long division. All right, so I'm going to set up my long division box here. And again, my dividend is 11, that's my numerator. And my divisor is 15. The divisor is already whole, so I don't have to worry about moving any decimal places. 11 is the same as 11 and 0 tenths, so this is where the decimal moves straight up. And 15 does not go into 11 at all. Okay, but we do know that 15 will go into 110. All right, 15 rather, goes into 110 6 times. All right, 7 times. That was my mistake. 15 goes into 110 7 times. All right, 7 times 15 is 105. And if I do 110 minus 105, I'm left with 5. Let's add a 0 and bring it down. 15 goes into 50 3 times. All right, 3 times 15 is 45. And when I subtract, I'm left with 5. We'll add a 0 and we'll bring it down. 15 again goes into 50 3 times, which was 45. Our difference again is 5. Add a 0 and bring it down. And there's that 50 again. 15 goes into 53 times. And I think we see what's happening. All right. So our fraction 11/15 is going to be equal to the decimal 73 hundredths, but the 3 is repeating. Okay, so again, right here in the hundredths place is where our decimal begins to repeat. So I'm only going to put a bar over that 3 right there. Okay, only put a bar over the 3 because the 7 does not repeat. 11/15 equals 73 hundredths with the 3 repeating. And this is an example of a repeating decimal because the decimal repeats in a pattern forever. Okay, if we were to continue this long division, we would keep getting 50 minus 45, 50 minus 45, on and on forever. So this is an example of a repeating decimal.